Remember now we are solving for the unknown. So I'm just going to highlight the unknown. The unknown is at x right there. Remember, the key thing is leave the unknown and anything attached to it for last. So we're not going to be troubling that 5x yet. Definitely there is a positive 3 that we need to get rid of. Mathematical principle is that it's adding to the left side. So you'll subtract a 3 and balance by subtracting 3 from the other side. Now let's walk through again. We're left with 5x, which is now equal to 18. Now remember now, 5 is being multiplied to x. So the inverse of multiplication is to divide. So in order to get the x by itself, we're going to be dividing by 5. So you could see 5 cancel 5. And whatever we do to one side, we have to do it to the other side. We divide by 5. X is equal to 18 over 5. You might be asking if there is a need to write your answer as a decimal. No, there's no need to do that. But if you had gone ahead and put it in decimal, you would have gotten 3.6. Negative 6 minus 3x. And this is equal to 12. Again, we're going to leave the subject and anything attached to it for last. And when I say subject, I'm referring to the thing that we want to find. So I'm not going to be troubling negative 3x as yet. However, there is a, as you could see here, there is a negative 6 that I definitely need to get rid of. How do I get rid of a 6 that is subtracting? I am going to add 6. So a negative and positive 6 cancel themselves. But whatever we do to one side, it is advised that we also do it to the other side. So I'm going to be adding 6 to the other side. Let us simplify this. Negative 3x is equal to 18. Now, at this time, we definitely need x by itself. The x is being affected by a negative 3. But if you should ask, what is the negative 3 doing? It is multiplying. So to get rid of something that is multiplying, you have to divide by negative 3. You balance the equation by dividing by negative 3. It cancels itself on the left side. X is now equal to negative 6. So if you should put this on your calculator, negative 18 divided by 3, because the 3 could go into it without a remainder. Please do not leave it as a fraction because it's definitely negative 6. All right, so I'm trying to leave a number of things on the board as I go forward. Let's go for number 3. It says 5, open bracket, 3p minus 2 plus 4. And this is equal to 16. Now, there are a number of ways you can approach this question, but I'll definitely say to you, what you could do very early if you want, and as I said to you, there are a number of ways. One of the things you could have done, which is to distribute this 5 right now inside the bracket. So you could just relax and start your distributive process. So we could just distribute right about now. So in this distribution, 5 times 3p will give me 15p, and 5 times negative 2 will give me negative 10. There was a plus 4 at the back, and this is equal to 16. So definitely this is where we're at right about now. Now let us simplify this, no rush. 15p, when a negative 10 is added to 4, we're definitely going to get negative 6. And this is exactly, thank you very much for that. So at this time now, we're going to save that 15p for last, which means that we're going to get rid of this negative 6 by adding 6 to both sides.
Get 22.
All right, so 15p, thank you very much, is equal to 22. And then we divide by 15. Exactly. So p is equal to
22 over 15.
22 over 15. And you don't have to put this as a decimal. It's fine. It's perfect as it is. What I want you to do is not to stress yourself over this. What you want to do is to first get rid of the fraction by finding an LCM for the denominator. So thinking about 5, you're thinking about 4. We want a number that the 5 and the 4 could go into without a remainder. So that's a 20, right? So then what we're going to do, so I'm going to write it here. We're going to multiply 20 throughout. So I'm putting some little things on the outside here. Throughout. So we're going to multiply everything by 20. We're talking about using the LCM to multiply by every term that was in the math. And we had 3 terms, 1, 2, 3. And if you notice, my 20 was used to multiply by all of them. Why did we do it? So that we can cancel. So now let's cancel. So let me just write it on the side as little notes. So I'll say to us, now let's cancel. But come into itself 1 time, 5 into 24. 4 into itself 1 time, 4 into 25. You see that now? The fraction is gone. All right? So the fraction is now gone. So what you're going to have now is 4 times 2, which is 8x, then 5 times 6, which is now 30, and that is equal to 40. Look at that. Let us do what we were doing before. We're going to leave the 8x for last. Get rid of this 30 by subtracting 30 from both sides. So now 8x is now equal to 10. And then we divide both sides by 8. Bam. So x is now equal to 8 over 10, or you can cancel down this by using 2. You'll get 5 over 4. So 8 is equal to, x is equal to 5 over 4. Done. Now we have to focus on the denominators. As how many? All right. All of the denominators must be taken into consideration when you're going to do this. There are 3 of them. 1 is 4, 1 is 2, 1 is 3. What number can they go into without a remainder? Somebody typed it. Somebody said 12. I agree. So we will multiply. See what's going on now? Multiply throughout by 12. We're doing it so that we could cancel. Just learn that. That's why you're doing it. So let us do it now. We're going to have 12 times 1/4. So we use it to multiply by everybody. Here it is. That's the 12 going with that. That's the 12 going with that. That's the 12 going with that. So it's just going. It's just going. Now, why did you do it? You did it so that you could cancel. So I'll say to you, no, cancel. Right? That's why you did it. So we're going to say 4 into itself 1 time. 4 into 12, 3. 2 into itself 1 time. 2 into 12, 6. 3 into itself 1 time. 3 into 12, 4. See that? There is no fraction left. There is a 1 at the denominator, which means that the fraction is dissolved. So what we're going to do now is to push further. We're going to carry out by simplifying what we have. 3 times 1 is 3, and then there's an equal sign. 6 times x becomes 6x. And -4 times 4, that's a -16. So I'm going to get rid of that -16. I am not going to trouble this 6x because it's not like I have a decision to say, let's gather them on the left side. It's only one thing with x on it. It is on the right side. It is okay to leave it there. So what we're going to do is the opposite, or what we call the inverse to -16. We will add 16 so that a negative and positive of 16 becomes a 0. But whatever you do to one side, remember, balance the equation and do it to the other side. Therefore, 19 is equal to 6x. Now, let's divide both sides by 6. Divide by 6. Bam, bam. 19 over 6 is equal to x. Or some people might want to say, no, x is equal to 19 over 6. Same thing. There's a +1. I'm saying to you, approach it the same way. We realize that we have a denominator thing going on. There's a 2, there's a 7. It is our intention that we don't have any because we can't work with the fractions. So we're going to try to get rid of them. What's a number that 7 and 2 could go into?
14.
LCM. Somebody says use 14. And you see this 1 times 14. So there were 1, 2, 3, 4. And if you notice, we have 1, 2, 3, 4. So it has to be used to be multiplied by all the terms, 5 times the 14, that's 70. But we could cancel here, 70 sub 1 and 7 into that 2. So you're seeing now, negative 2p times 2 will give you negative 4p. Equal sign is there. 2 into itself 1 time. 2 into the 14, that's 7. So now you have to say 7p times, 3p times 7, and that is 21p. And then now we have a 1 times 14 is 14. See, the reason why we multiply throughout by our LCM is so that we could cancel whatever number of fractions that we have. Then we simplify. Take a look at it. It will not resemble some other simpler type of equations that you have dealt with already. Now at this time, I'm just going to say, I'm going to just collect all my p's on the left side, which means I need to collect the numbers on the other side. So I'm just going to point to my intention. I don't need the 21p on that side. I need it to come over here. And you see this 70, I don't need it there. I need it to come over here. So that's what we want. So we're going to rearrange the ideas and so on. Somebody might say, but sir, what if I want to collect the p's on the right side and the numbers on the left side? You still can do that. Anything you want to do will work as long as you do not make any error while doing it. So I decided to carry the p's on the left side, which means that in reality, I'm going to take a long step though. What is going to happen is that the 70, you're going to have to subtract 70. You understand? And the 4p here, you're going to realize that you're going to subtract. So when I write this, I'm going to re-explain. See there? The 21p, you would have subtracted here first. And that 14, that is here, you're going to have a minus 70 beside it. Let us look. We're talking about this here. Right? We need that to be there. But on this side, we don't need this there. So that is why we subtract it from itself, and you balance by subtracting it there. That's why it is there. Also, the 70 here cannot stay here because we're going to collect p's on that side. So you subtract 70 and you have to balance by subtracting 70. Some people, the shortcut is to say that the 70 comes across and the sign change. Look at that. Or some people said, see the 21p go across and the sign change. If you want to say that, that's fine. I just want you to understand what's going on and you take your necessary steps. Let us simplify. We're going to have negative 21, no, my bad, negative 25p. And this is going to equal to, what's that? 56, negative 56. So it's like negative 25. You're going to divide by negative 25. So it should be a positive. So p is equal to 56 over 25.